I'm Michael Miller.
Hey guys, I'm Arturo Martinez.
Hi, I'm Matthew Pereira.
Hello, this is multisim. Here we're going to place components such as the AC power that we will be using. After placing it, you're going to double click it and type in the power source in RMS that you'll be We're using a volt source of 4.5 divided by 2, then multiplying its outcome times 0.707. We'll enter that in here. We will also be entering the hertz. In this case, we chose 500 hertz. From here, we'll be pulling the resistors that we'll need. We have one 100K resistor and one 15K resistor. The 15K resistor you will be rotating clockwise so that it's going vertically up and down. You also need a ground in order to ground out your circuit. So now that you have all of your components, you're going to connect them. From the power source, or from the positive side of the AC current power source, you'll be connecting the left side of the R1 resistor. From the right side of the R1 resistor, you'll be connecting to the top portion of the R2 resistor. And then from the bottom part of the R2 resistor, you'll be connecting to the negative portion of your power supply. Then you'll connect the ground. You'll right-click your segment color and change your segment color to black, indicating that this is your ground, or your negative side. Michael, I'm going to show you how to measure voltage peak to peak. First, we're going to choose our oscilloscope. We're going to connect it to our circuit that we've already built, ensuring that we include all of our resistors. And we're going to begin our measurement. Turn our simulation on. Get our data. Then we're going to zoom in for our readings. Move our place markers over. Go to our Y maximum and our Y minimum, and that'll give us our reading of 4.499 volts. That's voltage peak to peak. Okay, next we will measure the voltage across our power source, also known as volts RMS. We'll pull out our voltmeter. Okay, we'll place that. Connect it to our circuit. Positive on the positive side of the power source, negative to the negative side. We'll check our settings. Okay, we'll change this to AC. And we will start our simulation. We have a good reading. Shut off the simulation, and we measured 1.591 volts RMS. Next, we will use our oscilloscope to measure the time period for our wave. We'll open that up. And we will set our markers to a Y value of 0. And that'll give us our measurement of 2 milliseconds. And next, to measure our frequency, we will divide 1 by our time period of 2 milliseconds. And that gives us a measurement of 500 hertz.
Hello guys, it's Arturo and I'm going to show you how you measure your voltage across R2. So we select our voltmeter, our vertical voltmeter, plug it in our positive to our positive and the negative into negative. Make sure you have your AC selected. Start your simulation, give it a few moments to come up with an answer, and you can see clearly there that the voltage across R2 is 0.207 volts, which is, now we double click on our oscilloscope and we can clearly see, make sure you have B selected. That's our B input that we're working with right now. Grab our sliders, try to put as close to your maximum, put it closer to your minimum, and let me move this a little bit over. Make sure again it's on your peaks and your valleys, and use clearly there. You can see that that's our answer. Now we can measure our frequency. So we move snap our slider to the 0, a positive 0, up coming from 0, and we move our yellow slider, snap it to 0 again, and you can see right there it gives you an answer of 2 milliseconds. Remember that 2 milliseconds, it's 0.002 of a second. We divide that 1 by 0.002 and that gives us 500 hertz. Now I'm going to show you the DMM. So our DMM, as you know, is a function generator, as you guys know, and our oscilloscope. This is what we're going to use in our bench section of our lab and our breadboard. We connect our red leads in and our negative lead in, connect the positive to the positive and the negative to the negative. Right now the circuit doesn't have any power whatsoever. We go to our function generator. It's our BNC connection. Make sure it's on the 50 ohm output. Again, 500 hertz, because what we asked, we came up with a team for our frequency, positive to positive and negative to negative. And you can see that's your VRMS. Here on your oscilloscope, how your peak-to-peak values are. You can do it the old school way by counting each of the individual squares, and you know that each square it's 1 volt, so you count 1, 2, 3, 4, and that seems like it's about half, which coincides with the voltage that we chose, which is 4.5. To measure the time between each cycle, you move your horizontal axis as close as you can to 0, and you count your squares. Notice how in hours it's 500. So 2 squares will make it a millisecond. So you have 4 squares, about 4 squares to get to see from 0 to 0. 2 milliseconds. If you divide 1 by 200 by 0.002, that shall give you 500 hertz. Peak to peak, it's 600 volts, because you can clearly tell it's 3 squares, or almost 3 squares, so you can estimate that's about 300. Or VRMS, 600. VRMS, remember, it's half of the peak to peak divided multiplied by 0.707, which is 207 in perfect world. But however, we can kind of estimate that it's 200 because it's about the same amount per square. Our frequency, we can count. And now to figure out our period, we count our squares: 1, 2, 3, 4, 4.5, 4.25. So that's obviously going to give us a slight different answer. But remember, we're doing the old school way, which is not exactly precise. So we're going to use our formula to figure out hertz. So it's 1 over 0.00225. When we do the math, it's going to give us 445. And now I'm going to show you how to do it the new school way, which is you select your channel 1, which is the equivalent of channel A. You hit display. You go up one. You go to measure. Display all. And then you have your volume max, your minimum, your peak-to-peak voltage, your RMS, and then you go to time. You select time, and you go to time, and you hit with your knob, select frequency, and it shows you 500 hertz. And then hit time again. Time in your period, it's 200 milliseconds or 2 milliseconds. Alright guys, to measure your voltage across R2 the new school way, you go to your oscilloscope, hit measure, display all, and you can see your voltage peak to peak, your VRMS, and your frequency. To see your time, you hit time, select period, and that gives you your period of 1 cycle, which is 2 milliseconds. I hope you guys enjoyed this video, and have a good day.